We're asked to find the derivative of y with respect to x. So in other words, we want y prime. That's just shorthand. It's not explicitly saying it's with respect to x, but that's the only other variable here. So you're taking a derivative of this entire thing with respect to x. And every time you take a derivative with respect to x of a different variable, you should be writing y prime. Okay, the power rule still applies whenever it does. If that was y squared, the 2 would come down and multiply. But every time you take a derivative with respect to x of a y variable, you've got to have a dy dx coming out of it. You've got to have a y prime. Okay, so if I take a derivative of this one, look, it's two possible distinct functions of x. Y could be written as a function of x. So that means we need to use the product rule. It's the derivative of the first function times the second function kept the same, plus the first function kept the same. Oops, yeah, no, we're good. First function kept the same times the derivative of the second function. Now, this is the part we'll want to be careful on. I just took a derivative with respect to x of a y variable, so I need to have a y prime come out of it. Okay, so the derivative of the first function times the second function kept the same, plus the first function kept the same times the derivative of the second function. The derivative of y to the fourth with respect to x is this right here. Okay, and the goal is to get y prime by itself, dy dx. So I've got to solve for that. That means I want to get rid of this on this side. I'm just trying to have y prime terms. So subtract that from both sides, you get y prime plus, when I clean this up, that's 4x to the third y, y to the third, and y prime. That's what this term is. And then I move that to the other side. Almost there. Both these terms have a y prime in them, so let's factor out y prime. Left with 1 plus 4x to the third, y to the third. And our goal is to get y prime by itself, so my last step is to divide 1 plus 4x to the third, y to the third from both sides. And that's dy dx. That's the derivative with respect to x. Same thing on this one. I'm going to take d dx of everything. I don't know what y is as a function of x, so I'll use the power rule just like normal. And then the chain rule applies. The derivative of the innermost function, we don't know what it is, so we'll leave it as y prime. And then this one involves the power rule with the minus sign in front of it, so make sure you put your result in parentheses on this one. The derivative of 3x is 3, so it's the derivative of that first function times the second function kept the same, plus the first function times the derivative of the second function. And then the derivative of 1 is 0. Oh, I forgot something big here, right? This is the whole point of doing it. I took a derivative with respect to x of a y variable, so that means I need a y prime to come out of it. That was a big mistake on my part. So we can distribute that minus sign. That's a y prime, by the way, not a 1. Sorry. 3 times 5 is 15. X, y to the fourth, y prime. And I want just y prime terms in this side because that's what I'm trying to solve for. So let's add this 3y to the fifth to both sides. Then we can factor out a y prime from everything. And then the last step would be to divide this from both sides. So you're going to get y prime equals 3y to the fifth over 4y to the third plus 15x y to the fourth. There's our derivative with respect to y.